Today's lesson is solving exponential and logarithmic equations. My learning goal is I can solve exponential and logarithmic equations by using inverse properties, distributing, factoring out the greatest common factor, and dividing by the coefficient next to the variable. All right, let's just talk about what inverses are and what they do. So inverses undo each other. So examples of inverses are adding and subtracting, multiplying and dividing, squaring, and square root, just to give a few. So today we're going to talk about exponential and logarithmic equations. Undo each other. Okay, so we are going to start with an exponential equation. So I wrote down what I'm doing, and we are going to do the math on the right. So I'm starting out by looking at, I have two different bases. I have a base 5, and I have a base 10. So I have two different bases. So my goal is I want to get to the same base. So I have one with a base 10. So in order to undo the exponential part, I'm going to take the log of both sides. So I'm going to take the log of base 10 because 10 is one of the bases that I have. I could do it of 5, but I'm going to use 10. So I'm going to say log of base 10 of 5 raised to the x plus 2 equals log of base 10 of 10 raised to the 2x. Okay, so the reason I'm doing this is I want to eliminate some information. So when I have the log of 10 of 10, this literally becomes 1 because the exponential and the log undo each other. So I'm left with log 10, base 10, 5 of the x plus 2 equals 2x. So next, I am going to take my power and move it to the front of my logs. So now I have, and I need to write it as a parentheses, x plus 2 times the log of base 10 of 5 equals 2x. So the next thing I see is I have a term outside of the parentheses. So I'm going to distribute on the two terms on the inside of the parentheses. So this is x times the log base 10 of 5 plus 2 times the log base 10 of 5 equals 2x. So next my goal is I want x on one side. So I'm going to move 2x to the left. And 2 times the log base 10 of 5 is a number. It's a irrational number, but I'm going to move that to the right side. So I'm going to move 2 at once. So this is x log base 10 5 minus 2x equals negative 2 log base 10 of 5. At this point now I have two terms on the left with x, so I want to factor out x. So this is x, and I have log base 10 of 5 minus 2 equals negative 2 log base 10 of 5. And then my last step is I'm going to divide by what's next to my variable. So I'm going to divide both sides by log 10, log base 10, 5 minus 2. So I get x equals negative 2 log base 10 of 5 divided by log of 10 of 5 minus 2. And we are going to round 3 decimal places in my calculator, and I get x is approximately 1.074. So I just have a lot of words with logs, but I'm using a lot of the same process I have all along. All right, let's try another exponential equation. I'm going to do the same process. I am going to give you what I'm describing in steps, and we're going to do the math on the right. So now I see I have two different bases. I have a base E and a base 7. So I would want to eliminate one of these. So my calculator has base 10 and base E. So base 10 and E would be my first choices. So base natural log is base E. So I am going to take the natural log of both sides. So the natural log of E to the x equals the natural log of 7 to the 2x minus 3. Okay, so when I have the natural log of E, these two undo each other. So I'm just left with x. So I have, and then I also am going to, so that I'm just left with x. So I'm going to start one step at a time here. So then I have natural log of 7 raised to the 2x minus 3. Now I'm going to use the power product, and I am going to bring the exponent in front. So I have x equals 2x minus 3. So the parentheses are important. Natural log of 7. Next, I'm going to distribute. I have a term outside to my two terms on the inside. So I have x equals 2x natural log of 7 minus 3 natural log of 7. I want to collect my x terms on one side. So I'm going to move my x term from the right side to the left. So I have x minus 2x natural log of 7 equals negative 3 natural log of 7. Next, I want to factor out my x on the left side. So I have x, and I have 1 minus 2 natural log of 7 equals negative 3 natural log of 7. And then the last step, I want to divide by the coefficient next to the variable. So this is going to be x equals negative 3 natural log of 7 divided by 1 minus 2 natural log of 7. Last step, I'm going to put it in my calculator and round 3 decimal places. So I'm going to say this is x is approximately 2.019. And if you want to put this in your calculator, if you use the alpha y equals with the fraction, that usually works out pretty good. Okay, so let's solve some equations now. Solve the logarithmic equation. Verify. After I do it, I have to verify in the original equation. And I have to do that because I have domain restrictions. So the domain restriction was the log of a, base a of x, where x has to be, oops, what happened? Where x has to be greater than 0. So x has to be greater than 0. So I have a domain restriction. So after I solve, I need to go back and check in the original equations. Okay, so I am looking on the left side of my equation. I am in the expanded form, so I am going to condense it. And so I am looking at, I see I'm adding here, so that means I need to multiply when I condense. So natural log of x minus 2 times 2x minus 3 equals 2 times the natural log of x. Okay, so the next thing I want to do is I want to undo the natural log. So I'm going to exponentiate. So to exponentiate means I am raising it to an exponent. And my base is e for natural log. So I want to raise it to base e. So I'm going to say base e, and then I'm taking everything that I have, ln x minus 2 2x minus 3 equals whatever I do on the left, I have to do on the right, 2 ln of x. Oh, I guess I'm going to do one thing first. Here. I am going to bring this exponent up here. So this is e ln x squared. Okay, then I'm going to use my inverse property so that I know when I have base e raised to the natural log, these two, exponential and logarithmic, are the same base, undo each other. And I have that on both the left side and on the right side. So what I have left is x minus 2 and 2x minus 3 equals x squared. Okay, so I'm going to double distribute. So I have 2x squared minus 3x minus 4x plus 6 equals x squared. Okay, I am going to subtract an x squared from both sides. So I get x squared, and I'm going to combine minus 3x and minus 4x, and I get minus 7x plus 6 equals 0. I want to factor. I know my signs are the same. They're both negative. So this is x minus 6, x minus 1 equals 0. So I get x equals 6 and x equals 1. Next, I have to verify in the original equation. And I have to make sure I'm greater than 0. So if I go check and substitute in 6 minus 2 is 4, so that's positive. And 2 times 6 is 12, minus 3 is 9, that's positive, and 6 is positive. So 6 checks out. I verified 6. If I check 1, 1 minus 2 is negative 1, so I cannot take the natural log of a negative number, so this one does not verify. So my solution is just x equals 6. All right, let's try one more. Okay, so this one, my base, I'm always interested in what's the base. So on this one, my base is 5, and I see that here and here. So this time I'm seeing I'm expanded, and I'm subtracting. So when I condense it, I know I'm going to be dividing. So this is going to be log of base 5 of x plus 1 divided by x minus 1, and that equals 2. So to undo the logarithm, I want to exponentiate, and I'm going to exponentiate by the base that I'm using. So the base I'm using is 5. So I'm going to say 5, and I'm going to raise everything. Log base 5 of x plus 1, x minus 1. And whatever I do on the left side, I have to do on the right side. So I am exponentiating the right side. So what I have is my inverse functions undoing each other. So I have exponential and logarithmic of the same base. So these undo each other. So I'm left with, on the left side, I'm bringing this down to the front. So this is x plus 1 divided by x minus 1. And 5 squared is 25. So now I'm in a cross multiply. So I'm distributing 25 over x and negative 1. So this is x plus 1 equals 25x minus 1, or minus 25. So I am going to subtract x, 1x from each side. So I get 1 equals 24x minus 25, and then I'm going to add 25 to both sides. So I get 26 equals 24x. So I get x equals 26 divided by 24. When I simplify, that's 13 over 12. Which, if I want another exact number, I could say 1.083 repeating. And I need to verify in the original equation, so 1.083. So x plus 1, that'll give me a positive number, and x minus 1 will give me a positive number. So it checks out. So I could either show this exactly as a fraction or as a repeating decimal. Either one works, but I want to show it exactly. Okay, last equation, last example. Okay, I have a logarithmic equation. So I'm going to start by, I want a 1 in front of log. So I'm going to start by dividing by 3. Whatever I do on the left, I need to do on the right. So I get the log base 3 of 4x minus 7 equals 2. So I want to undo my logarithm, so I need to exponentiate. So I'm going to exponentiate using what the base is, and I know the base is 3. So I'm going to exponentiate log base 3 of 4x minus 7. Whatever I do on the left, I need to do on the right, so I'm going to exponentiate the right. So on the left-hand side, I have some inverse functions undoing each other. So 3 raised to the log of base 3 undoes each other is 1. So I have 4x minus 7 equals 3 squared is 9. So I'm going to add 7 to both sides. I get 4x equals 16. So x equals 4. I'm going to go verify in the original equation. So 4 times 4 is 16. Minus 7 is a positive number. So I have verified x equals 4 works. So in the big picture, I want to understand inverse functions undo each other, whether I'm talking about base 2, base 10, base e, any base. So when I have the exponential and the logarithmic of both, they undo each other. So this is the big picture right here.